discussion for geomorphology, question number 2 in paper 1 in our geograph paper. Right, we are going to go through the basics of geomorphology and also combining it with the practical aspect of Mapwork and GIS concepts. So we are going to have a run-through discussion for our study guide, our guide that we use for geomorphology. We'll be just using it as our guide for the discussion, and mainly we want to focus on examinable areas so that we prepare you for the coming examinations. So this presentation is going to be equally beneficial for you as you prepare for the examinations. So what you're going to do here, I'm going to go through the basics of geomorphology, and we might not need to spend much time on the concepts there. What I would want to do is to use an illustration so that it becomes clear on you to understand some of the basic concepts in geomorphology, because they are also equally important. We get questions where you're supposed to define those basic concepts. Right, so to start with, we have aspects like drainage basin, aspects like the catchment area, river system. Right, we just want to try and illustrate the application of such concepts on a given illustration. Right, we're going to use this illustration that we have here. Right, if we see, when we talk of a river source, we are looking at that place where the river originates from, or where the river starts from. That is the source of the river. Like if you can check here, you can see that there's a river which is just starting from that particular high-lying area. And our sources for the rivers, remember, usually most of the rivers, they start in high-lying areas like in the mountains. So the source, that is the basic point of start of a given stream or a river, where it starts, or where it is originating. Right, and then we also have what we call a tributary, like what you can see here. Right, a tributary basically is a stream that feeds into the main stream. We have a smaller stream which feeds into the main stream, and we also need to note the confluence. What is a confluence? A confluence is the exact meeting point or the joining point of a stream and its tributary. Like if you can check here, there is a tributary coming from this side, and there is a major river which is coming from that direction. They are meeting at this particular point. So the meeting point of the tributary with the main river, that is the confluence. Then we also have another term that we call the mouth, like you can see as indicated here. The mouth, that is ultimately the end point of the river, where the river is now feeding its water or its discharge into the sea. So the end point of the flow of the river, where the water now is getting into the river, that is what we refer to as the mouth of the river. Right, again, we need to look at the interfluve, like what we can see also there. Right, and the watershed. I want to illustrate or to try and make it clear between those two concepts, because usually they are not well understood by most of the learners, and sometimes they fail to distinguish between those two, or they will end up assuming that those two are the same. Basically, a watershed is not the same as an interfluve. The difference here, what I'm going to illustrate, the watershed, we are saying, is a high-lying area which splits or which separates two different river systems. Let's assume we have a particular river here and its tributaries. This is river, maybe river A, and there's a high-lying area here, and again on this side we have another river with its own tributaries, which will imply that this is a drainage basin on its own, and also this is a different drainage basin. This is a particular river system of river A, and we have a particular river system of river B. These two river systems are split by this high-lying area. This is what we call the watershed. So the watershed splits two distinct drainage basins or two distinct river systems. They are split by a high-lying area, which is the watershed, or in some other texts, you tend to find that they use the geographical term, the divide. It's basically the same thing. If you find a textbook which is talking of the divide or a textbook which is talking of the watershed, it's basically one and the same thing. That is with the watershed. Then we also need to take note of the interfluve. Now what we call an interfluve, let's use stream B here as an illustration. You are seeing that there is one tributary here and there's another tributary here. These tributaries are of the same river system. They are within the same drainage basin. But however, the two tributaries will also be split by some high-lying area. So the difference here is now that an interfluve is now separating, it's a high-lying area which ultimately separates streams within the same drainage basin, or it's streams of the same river system being split apart by a high-lying area. This high-lying area is within one drainage basin, is working on one river system, but this one is distinguishing two completely different river system, or is separating two distinct drainage basins. So that's the difference between a watershed and an interfluve. Right, we cannot waste time on that. We want to touch on key aspects. Right, what you should also note here, usually you get questions that relate to the influence on infiltration and also the influence of surface runoff in relation to a particular area. So these are just basics, or this is information related to the influence of factors that influence infiltration of water and ultimately surface runoff. Right, I'm going to elaborate on those two aspects. Right. Infiltration here, I think it's a common term that you must be aware of. We're talking of infiltration. We're looking at the seeping of water into the ground. When we receive rainfall, the rainfall will gradually seep into the ground. That is the infiltration part that we're talking about. And if the water does not filter into the ground, it means now it becomes part of surface runoff. So those two, they work in opposite of each other. If there is infiltration, if infiltration is high, it will also mean that there will be less surface runoff. If it means the water is getting a chance to filter into the ground, it means there is more infiltration, and apparently there will be less of surface runoff. So those two, they work hand in hand, or they work in the opposite direction of each other. If this one is high, it means surface runoff will be lower. And in area where there's surface runoff, which is more, it means there will be less infiltration. What are the factors? Amount of water already in the ground. If the ground is already saturated, it means it cannot absorb in more water, or cannot allow for more water to filter, because the holding capacity will be exceeded. Evaporation rates. It also means where there's high evaporation and there is less water for infiltration. For example, in the hot areas like in the arid regions or in the desert areas, you tend to find that the rates of evaporation will be very high because of high temperatures. The water does not find time to infiltrate into the ground. Rather, it evaporates because of the high temperatures. Then also gradient of the slope. When I'm talking of the gradient, I think you know what gradient is as a basic concept under Mapwork. Right, we're looking at the steepness of the landscape here. Steep sloping areas, they do have more of surface runoff. And general sloping areas, they have less of surface runoff and more of infiltration. If the gradient is general, it means the water will find time to slowly sink into the ground. But if it's steep, it means the water won't find such time and is only forced to overflow the surface as surface runoff. Then nature and amount of precipitation, it also a determining factor. If we have light precipitation, like little rainfall, it means that the rainfall will be able to filter into the ground slowly. But if we have heavy rainfall, usually it compacts the ground because of the impact of the drops of the rain, which will be heavy, and it will promote more of surface runoff and less of infiltration. Right, these are some of the factors just in passing, but you should be well aware of them, and you should be able to figure out how they affect those two processes of surface runoff and also of infiltration. Right. In as much as that is concerned, we need to also check on typical questions. These are low order questions which are related to the basics of geomorphology, where water that flows on the surface after rains, we've talked about that, that is surface runoff. High-lying area that separates two rivers in the same drainage basin, we've also elaborated on that. If it's in the same drainage basin, we have differentiated between an interfluve and the watershed. The interfluve is the one which is within the same drainage basin. Then water found below the earth's surface, a river that flows throughout the year. There's also something that I might need to maybe to elaborate on when we go to the types of rivers, but however, that is going to follow in the coming discussion. Right. Then there's another aspect of drainage density that we might also need to check on. We need also to know about drainage density of a given area. Right. What we call the drainage density in this instance, we are looking at the number of streams in a given drainage basin. And that will lead us to the geographical effect of high drainage density areas and low drainage density areas. Meaning to say, where we have so many streams developing, we have an area which we refer to as a high dense drainage or high dense drained area. It's high density because the streams are many. If we were to look at the number of the streams in the basin, if there are many, then it's high density. And it also relates to these factors now, these factors that affect infiltration and surface runoff. Where there is more infiltration, where there are factors that favor infiltration, they will be low density. For example, in areas where the rocks are very permeable. Rocks which are permeable and soil which is permeable, it means it's got allowance for water to pass through it. And those areas, it will also mean that they will promote more of infiltration and less of surface runoff, which will result in lower density. There's fewer streams which are going to develop in those areas because much of the water is fed into the ground and does not find time to flow over the surface. So you need to relate drainage density to those factors that affect or factors affecting infiltration and surface runoff. So we are saying of high drainage density, where we have quite a large number of streams, and low drainage density is where we have less number of streams. So typical questions that you might get may be related to Mapwork. A question might ask you, compare the density of given blocks. Compare the density of block B4 and the density to the density of block C2 on the topographic map. You just have to figure out from the given blocks and check which one has got more streams and which one has got less. The one with more streams, obviously, is the one that is a high drainage density area. And also the one with less is the less drainage density area. And also, besides checking on the number, you can use the cumulative length of the streams. If you were to add all the streams to make them one in that particular basin, how long were they going to be? Like, what am I saying here? We're saying that you find that there are streams in a given, maybe it's a question relating to a given block. There is a block and maybe there is one main stream and there are the tributaries there. And then if there is a comparable block, again, where we are supposed maybe to compare, you tend to find that maybe in this block, the streams are something like that. If you are to compare the density, you can compare the density by looking at the number of streams. This is a low density area, and this is a highly drained area. If you are to use the number of streams, we are saying there's a stream there 1, there's a stream there 2, 3, 4, maybe in the main stream. Then That is the maximum number of streams that we can have there. Then if you check here, we have 1, 2, 3, 4, 5, 6. There are so many. So which means using the argument of number of streams, the one with more streams, the high number of streams, the one which is high density. Or if you are used to use cumulative, the length of the rivers. If we were to add them, to make them one, you tend to find that if we add streams here, they are going to give us a long stream, or a long stream at the end. But if we add up all these, they will just maybe give us a relatively shorter stream. So that is basically the basis of what we call drainage density. Right. And let's move on and try to look at the other basic aspects of our discussion. Right. We are relating this to Mapwork application or concepts here. If you find, like, for example, what is F? Given now that you are now applying the basic knowledge that you have of geomorphology, you should be able now to relate it to the given map situation. If, for example, the question is saying, identify this feature F here. Obviously, we are seeing that there is a stream which is coming from there and a stream which is coming from this side. These two streams are meeting here. That would definitely mean that this is the confluence of those two streams. They are meeting at that particular point. Or if you can check here, area C, if you check area C there are some contour lines which you can see on this gray area, indicating that this is a high-lying area. And this high-lying area, there is a river system which is indicated as A here, which has got this dam and which continues in that direction. Then if you also check on the western side, there is another stream there which is also indicated with its tributaries. So definitely area C, if you get a question which is asking about what area C is, it means definitely area C, that is the divide, or that is the watershed, because it's basically splitting one river system on the other side and another river system on the other side. So those are the basics that you should apply in terms of the concept of geomorphology, relating them to Mapwork. Right. We might not need to waste much time there. And also, maybe the other question that you need to also to note is the direction of flow of a river is one of the most critical things under Mapwork that learners usually fail to figure out. If the question says, identify the direction of flow of a particular river, there are basics that you should always refer to that will give you a clue of how the river is flowing, in which direction the river is flowing towards. Right. I will just maybe make an illustration and try to highlight from the map to show those particular aspects. Right. What you need to check first, you can check on the clues on height. Check on the indicators of height. What are the indicators of height on the map? We know well that on our maps, the topographic maps, they give us the shape of the landscape. We have indicators of height on the map. Like, for example, you can check for contour lines. These brown lines that you are seeing there on the map, these are typical contour lines that you are talking about. So those ones, you can use them to determine the nature of the landscape. Which side is higher and which side is lower, by reading the contour lines. Right, that is number one. You can use the clue, the indicators of height, which can be a contour line, or you can use the benchmarks. And you can also check on spot heights. The geographical sense is rivers will start from high-lying area going towards low-lying areas. So where you see indicators of height, which are showing that the height is much more higher than the other side, definitely the rivers will be coming from that particular high-lying area, flowing towards the low-lying area. That is what you check for using the clues of height. Then you can also use the indicators here. Let's now relate maybe the indicators of height to show maybe where this river is flowing towards. If you can try to figure out, unfortunately, our contour lines are not very visible, and the indicators of height, but the indicators of height you can see, we have 220 on this contour line, we have 203 on that spot height, we have 222 on this spot height, and also you can check we have 177 on this particular area. So what is the implication? It means this area here is a high-lying area with heights above 220. And this means this area is a little bit lower with height of 203 meters. And this one is slightly lower with a height of 177 meters above sea level. So those are the indicators of height that are equally important, that can guide you also to determine the flow direction of the river. Then, besides using the indicators of height, you also need to check on the contour lines. Here in this instance, you check the sequence of the contour lines as they cross a particular river. If we have a river and we have contour lines which are indicated, which coincide and cross that particular river, they will have a specific or a particular pattern which they are going to be portraying. Like, for example, we are saying we have a stream like this. The question is saying where it identify the direction of flow of this particular stream here. Right, without you taking the indicators of height, or without you using the other indicators of height, you can figure out by the sequence of the contour lines. Right, what is going to happen is the contour lines will bend upwards upstream as they cross the stream, like this. If this is a contour line, when it crosses the river, you can see that it's bending upwards like that. Another one will also come, it will bend upwards, it will continue like that. If there's another one, it's going also to bend upwards and like that. So where the contour lines are bending towards is where the river is coming from, which means this river here, if the contour lines are having this sequence, the river is going in that direction, is flowing, going in that direction, because of the nature of the contour lines as they cross the river. Right. And also what you need to check there is, besides checking the contour line pattern, how are they bending as they cross the river, you can also check on the areas where the tributaries are joining the main river. Right. Usually when we have a dendritic drainage pattern, we tend to find that the tributaries, they will join the main river at acute angles, which will imply that if the acute angle is facing this direction, the river is going that particular direction. The tributaries will join at angles less than 90 degrees like this. If the tributary is joining like this, the acute angle is facing that direction, the river is going in this particular direction. So basically, those are the indicators that you can use if you get a question which is asking you about the direction of flow of a river. And usually you have to give motivation. You have to support your answer. The first part is for you identifying or determining the direction of flow, and then you give supporting geographical evidence from the map. So those are the pieces of evidence that you can use to ultimately support or motivate your response. Right. We move on to the next aspect. We are now looking at the types of rivers. Right. We're not going to waste much time on the types of rivers, though it's equally important for you to understand them. Right. The first type of a river that we have is a permanent river. When something is permanent, it means it's there to stay. Something that happens throughout. So we have rivers that flow throughout the year. Those are typical of permanent rivers. You can give typical examples of South African rivers, like you talk of the Vaal, you can talk of Orange River, you can talk of Tugela. Those rivers, they flow throughout. They do not have a time when they dry up. They will be having water throughout. What feeds water into them and what makes them flow throughout the year is the water table. What we call the water table, we are referring to the upper limit of the zone of saturation. Here, if you check, this level is indicating that below this level, there is permanent saturation, which is during the rain season. Because of feeding in of more moisture due to high precipitation levels in summer, the level of zone of saturation will be elevated. It will be slightly higher. It gets higher because there's more water being fed into the groundwater storage. So it also tends to have high levels of that particular water table. And then in the dry season, the water table drops because now there's less moisture being fed into groundwater storage. Our water table for the dry season, you can see it's indicated by the dotted line. So if a river is coinciding with both the dry season water table and the rainy season water table, it means that river won't run out of water, because even if it's dry season, the river is still managing to intercept the water table of the dry season. Like what you are seeing here, the river is ultimately going below the level of the dry season water table. So this river will flow throughout the year. It will decline because of the decline in the water table during the dry season, but it does not dry. And however, when it's rainy season, it has got very high discharge. Right, we go to the periodic. Right, something that is periodic, we are saying is for a particular period. It's not throughout. Permanent was throughout, or perennial, running throughout the year. Periodic, we are now looking at seasons. A river which flows in a particular season is periodic. A season is a period of time. It's not the whole year. And it's non-perennial, meaning to say it does not run throughout the year. This water table, this river here, its relationship with the water table is that the dry season water table is way lower than its riverbed here. The riverbed, you can see, is elevated. The dry season water table is somewhere there, which means when it's dry, the zone of saturation is only starting from this level going downwards. This river will not be having an effective supply of water into its river channel, and will ultimately dry out in the dry season. It can only flow when it's intercepting the rainy season water table here. So it's periodic, or it's seasonal, non-perennial. Then we move on to episodic. Right, an episode basically it's a short period of time. So it's not a season, it's just a very short period of time. We have rivers that flow after every rainfall. For example, rivers in the arid areas or in the desert areas, we have incidents of what we call the flash floods, where we can experience maybe very high amounts of rainfall in the dry area. Those rivers, they tend to flow when the heavy rainfall has just been received. But soon after a very short space of time, those rivers will apparently get to dry up, which means those rivers, they do not even have any intersection with the water table, like what you are seeing here. The river channel is up here. The rainy season water table is there, and the dry season is even lower, which will mean these rivers can only get to have water after heavy rainfall. And when the water seeps into the ground, it now goes to the rainy season water table, which is even lower than the bed of the river, and the river does not have water flowing in it. Then we have exotic rivers. All right, the term exotic here, it means the river is not conforming to the climatic conditions of the area through which it is flowing. For example, we can talk of major rivers as exotic in other areas. For example, the Nile. Where the Nile River originates, it goes through quite a number of countries. If a particular river is going through maybe a dry area, it's a river originating from a high rainfall area, maybe it's starting from the equatorial region, then it flows through a desert. It will not dry because it's going through a dry area. It will continue to flow because it's getting its supply of water from a humid region. So when we're in a desert, all the rivers which are starting from the very same area will be dry because the water table will be very low. But that particular river will be flowing, which now resembles that there is no conformance between the nature of the river and the climatic conditions over which the river is flowing into. It's a desert area. We expect the rivers to be dry, but there is a river which is fully flowing. That river is an exotic. It is permanent there, but however, it's exotic in the sense that it's not conforming to the climatic conditions of the climatic features of the area in which it is flowing through. That is typical of an exotic river. So usually get questions which require you to maybe explain those rivers in relation to the water table and be able to figure out how those rivers differ in terms of their discharge because of the position of the water table. So basically when we are checking on those ones, refer or relate to the level of the water table, whether it's the dry season water table or the wet season water table, you check and relate them to their intersection with the level of the water table in a particular season. That is going to guide you for you to be able to determine if a river is permanent or it's seasonal or it's episodic or it's an exotic river. That is basically with the drainage with the types of rivers. Right, we move on to drainage patterns. Right, when you're looking at a drainage pattern, I think we can see we have different shapes which are being portrayed by these rivers as they join with each other. Right, like if you can check here, this is a common drainage pattern. This is a dendritic. Dendritic, which is a Greek word relating to a tree and its branches. If you check this this drainage pattern here, it is more or less resembling a tree with its branches. So, and also if you check the size of the angles through which the tributaries are joining the major river, they are joining them at an acute angle, an angle less than 90 degrees, which also implies that is typical of how a tree is and its branches will be resembling. So this is the first drainage basin, which is most common, which is dendritic. Then we go to trellis. Trellis, the difference there that you need to note with dendritic, you can see the difference is in the size of the angle at which the tributaries join the main river. Right, this one we find it in areas where there is uniformity in terms of resistance to erosion on the underlying rocks. If the underlying rocks are of equal resistance to erosion, we tend to find that we have the dendritic pattern developing that particular area. And with trellis, you can see now that the shape is no longer the same. The angle at which the tributaries are joining the major river, they are joining at right angles, or they are ultimately having this 90-degree angle at which they are joining on the confluence with the main river. Right. This happens in areas of alternate hard and resistant and soft rocks. When we have a typical situation like this, you see this is a ridge. This ridge here, maybe it's a fold, and again we have another ridge on the other side. This will imply that we have hard and resistant rocks by the ridge area here. While we have a valley in between, this valley is going to cause the development of the major river along that particular valley. And the tributaries, they won't be as long as the major river. Why? Because they are bound by these bands of hard and resistant rocks which are forming those ridges. So it means if there is a tributary developing from either side of the valley, the tributary is going to be shorter because it's limited by the hard and resistant rocks on either side which are forming that ridge. That is why you tend to find that we are having these tributaries. The main stream will be much longer compared to its tributaries because they are limited. It's most likely we are having layers of hard rocks here, layers of hard rocks. The alternative softer rocks are the ones that will be in the valley where the main river is going to effectively erode and create a longer river or a longer stream channel along the low-lying area in the valley. Right, that is with trellis. I'll move on to radial. Right, I also want you to note the difference here before we have a confusion. Right, when we're talking of radial, we are saying the streams are starting from a common area which is high-lying and they are going towards different directions, radiating, coming from one central point, but moving into different directions. So in this instance, usually we have typical landforms like the volcanic domes. Where we have a volcanic dome or where we have the volcanic mountain, usually we have a lake on top of the volcanic feature, and that lake will act as a source of supply of water for the developing streams around the dome area. And meaning to say the central point is elevated, is high, and is where the rivers are originating from. It will mean that, like for example, if you check here, the volcanic mountain is here with the caldera lake on top of it, and the streams will radiate in given direction, in different directions. They are all starting from the same source, around the focal point of this dome, but however, because of the differences in elevation and differences in gradient around this geographical feature here, they are going to radiate and flow into different directions. This is the opposite of the centripetal drainage pattern. This is radial, and when we have a low-lying area, or maybe it's a marshy area, it means the surrounding areas will be higher and the rivers are going to feed into the low-lying area. This one now is the opposite of this one. Radial, they were starting from a high-lying area, radiating into different directions. But for this one that we are having here, for the centripetal pattern, this one is touch on it, we are seeing that this one now is a low-lying area. And these rivers are now feeding into the low-lying area. They are starting from the surrounding highlands and they are feeding into one common low-lying area, which is a basin structure. So you must not confuse the two, not confuse radial with a centripetal, because the streams will be going into different directions. Remember, centripetal is a basin shape, the landscape, and radial, it's a dome shape for the landscape. Whenever we have a dome shape, streams will radiate from the focal point, which is elevated. When we have a basin shape, or the streams are going now to start from the high-lying area and feeding water into the marshy area, which will be central, or which will be the focal point of that particular landscape. So that is the difference between those two. And when you are relating them to make Mapwork, the aerial view usually appears to be the same. It will be the same because if you are taking an aerial view of radial, like here, it's more or less the same as the aerial view of this one. But what you should now note is, if the question is asking about the type of pattern, is from a topographic map, you now have to use your skills of figuring out the height of the surrounding areas. If you see maybe there's a spot height inside here, which is maybe giving you a height, maybe it's 1,240, and you find maybe there's a contour line around here. The contour line is written, maybe it's 1,300. Definitely, it should lead you to the understanding that the central point of this feature is low-lying and the outer parts are high-lying. And then what kind of drainage pattern is going to develop there? The streams will be originating from the higher-lying area surrounding and will be feeding into the low-lying area, which is the basin. So it's centripetal. If it's the opposite, a volcanic dome, you check the central point. If it's elevated, you see maybe there is an indication of height there. Maybe there's a trig station which is showing a higher value, and you check the contour lines surrounding, you see that the value is decreasing. Then it means the system which is going to, the pattern that's going to develop there is going to be the radial pattern. Right, then we go to rectangular. Rectangular here, you can see it's rectangular in the sense that the rivers are more or less forming a rectangular shape. The streams are going and are bending at right angles, and also they are joining at right angles to the main stream. And also the tributaries on their own, they are also having a rectangular shape. They are portraying a rectangular shape. They all have 90-degree bends. So what causes such to happen is because of the underlying rocks, where we have an area with underlying rocks which has got cracks or joints, like what you are seeing here. These underlying rocks are having cracks on them and are having joints. The rivers, remember, they have to flow over areas of weaknesses. A river can effectively form when there is weakness in terms of erodibility of the surface. So our rivers will tend to flow through areas of weakness, which are the joints now. So the shape of the river and its direction is going to be determined by the cracks which are in the rocks underlying, such that at the end we have rivers following those cracks and creating right angle bends and also creating right angle confluences with the main streams. That is with the rectangular pattern. Then we go to the last one, which is deranged. Deranged is not very common, but it's also a typical drainage pattern which happens in areas where there is a typical of glaciation in most instances, where there is melting ice. If there is some ice which is accumulating, and because of the temperatures, the ice will gradually melt, and the melting ice is going to create streams or rivulets which are going to flow in different directions. Like if you can check the shape here, there's no definite shape for this one. The streams will just flow in any direction from the glaciers. That is typical of drainage patterns that we find mainly in the cold climatic regions. Right, then the last one is parallel. Parallel, I think you can see the streams are running at equidistance from each other. They are parallel in the sense that if they were to continue, they would not meet these streams. They are almost appearing to be having the same distance between them throughout. So this one here is a drainage pattern that forms in areas where we have parallel and elongated landforms. Like if you can see here, we have some form of some ridges here, and these ridges are parallel, which will also imply that if there is a river developing in a valley between these two ridges, that river is going to run at equidistance from the river in the next valley, and is going to portray the streams as are parallel to each other because they are bound by those physical features which are splitting them, and they will tend to have a flow which is parallel from each other as they are being bound by the existing geographical landscape. That is basically with parallel pattern. So what you should note here is you should be able to figure out those patterns on the map. You are usually asked on figuring out the type of drainage pattern in a given area or the dominant. The other confusion that might come there is if the question says the dominant drainage pattern, not the whole block, and see which one is more common. Because in some other blocks, you might be having two patterns in the same block, but one maybe is evident on just a particular smaller place in that block. It means that you have to check and find the one which is more prominent and the one which is having more evidence in that particular block. That will be the dominant drainage pattern in that particular block. Those are the typical questions relating stream patterns or the river patterns to map scales. Right. These are typical questions relating to the drainage pattern. The moment you understand how the drainage pattern is like and you understand the nature of the underlying rock that causes such a drainage pattern, then apparently you are now able to answer these particular questions because the description is either based on the underlying rocks of that particular area or is describing the nature at which the tributaries are joining the main river, or the description is describing the nature again of whether the landscape is a dome-shaped landscape or is a basin-shaped landscape. Then you should now be able to relate those descriptions to the given type of drainage pattern, given that you understand the underlying basis of the development of such patterns. Right. For example, if you can figure out here, it says it occurs in areas of folded sedimentary. You know now that the geology of the area is folded. What kind of pattern is going to develop when we have folds? Or a pattern found on a basin-like structure. Given that now you know what a basin is, it will also make it easier for you to figure out the nature of the pattern that is going to develop. Or if we check a question like tributaries join the main stream at acute angles, you know what an acute angle is and which pattern has got tributaries joining the main river at angles less than 90 degrees. You now apply because you'll be having the basis and now we'll just be figuring out the described pattern from the given description. Right. We move on to the next part. This is relating the types of rivers to Mapwork. It's a map extract whereby there are typical rivers that you can see there, and we need to relate Mapwork concepts to the geomorphology study of the shapes or the patterns of the rivers. Like if you check area D, if the question is saying maybe what is the dominant drainage pattern in area D, you can see how the streams are portraying what kind of shape is being portrayed by these tributaries here. Is now in application. you know the types of drainage patterns, and now you have to figure it out from the map. What is the dominant one? What is the most likely? And also, if you check at C, you might also need to figure out the drainage pattern in area C. You are seeing that these rivers are feeding into the blind spot river dam here, which means this is a low-lying area. And also, if you check your heights, it will indicating that these areas are higher here. And it means the streams are coming to feed into the low-lying area, which means this area is a basin shaped area. Right, that is relating it to Mapwork. Right, we move on. We go to density. I think with density, we have briefly explained what drainage density is. When you're comparing density, you're looking at the number of streams, and you're also looking at the cumulative length of the streams if we were to cumulatively add them to each other. So that is basically with a drainage density. So if the question is saying which one is higher density, area A compared to area B, it's clear you can see that the streams in B, they are fewer, and the streams in A are more. So this is a high and this is a low. And also relating it to the factors that we have discussed previously, factors that cause high density are factors that relate to high surface runoff. In areas that cause low density, it means there will be more infiltration in those areas. And we have discussed previously on those drainage, on those factors that affect infiltration and apparently surface runoff. Right. Diagram below represents drainage densities. That is with density. It's a simple question. When you get such a question, always remember the number of streams in the drainage basin. Then you will figure out how to answer the question. Right. Let's go to stream ordering. I'll quickly do the ordering so that maybe you can understand it. Right, what we call stream ordering, we are saying streams are ranked in the drainage basin. We rank them according to their orders. So we have what we call the first order, we have the second order, we have third order, going like that. The higher the drainage density, the higher the order of the streams in the drainage basin. But if it's low density, we will also have low order of the streams. Right, so the ordering that we use the sequence of 1 plus 1. The first order stream is a stream that does not have tributaries. It's an independent stream. A stream which is not fed into by any other stream. It's just itself. That is order number 1. So if stream number 1 joins another stream number 1, they are going to give us the second order stream. Again, if second order is joined by stream number 1, the order does not change. It remains as 2. If we are adding a higher order to a lower order, the result is the higher order in the addition. Then if stream number 2 is joined by stream number 2, it is going to give us the next order, which is number 3. And again, if stream number 3 is joined by stream number 1, we maintain the size of the first order. If number 3 is joined by number 2, again, the result does not change. It maintains the result of the higher order between the two. Then until we get to 3 plus 3. If stream number 3 is joined by number 3, they are going to give us the next order, which is order number 4. So the sequence continues like that. That is what we call stream ordering. So let's relate to this indication here. This is number 1. It's an independent stream, does not have a tributary. This is number 1, does not have a tributary. There is a confluence here. The two streams are meeting. 1 plus 1 is now changing to 2. That is why we're having 2 there. And again here, this is number 1, doesn't have a tributary. At number 1, they are joining here. They are going to give us the next order, 2. And this is number 1 is joining number 2 at this confluence. The order is not going to change. It will remain as 2. That is why there's 2 here. So it means on this part of the river, it's at stream number 2. But starting from this confluence here, we have number 2, which is being infused into number 2 again. The order now has to change to 3. And again, if there was number 1 here, this number 1 joining number 3 was not going to affect anything, was going to remain as 3. Or if we're having stream number 2, stream number 2, which is made up of 1 plus 1 to give us 2 here. If this 2 was going into 3, it was not going to change the order. It was going to remain as 3. And for this order number 3 to change into 4, it needs to be joined by another stream of the same order, which is third order. So it means for us to have third order is made when we have 2 second order streams. So what are we saying? For us to have number 3, we must be having number 2 joining with number 2, which means starting from here, it's now number 3. And for us to get number 2 comes from number 1 plus number 1. And also for this to be number 2, it must be made up of number 1 and number 1. So number 1 plus 1 gives us 2, 1 plus 1 gives us 2, 2 plus 2 gives us 3. Then 3 plus 3, after this, it was going to develop into the 4th order stream. So you see, for us to attain order number 4, we will be having a high density. The streams will be many. So which means in high drainage density areas, there will be higher order streams because the order will be attained by the joining of smaller streams until they give us a higher order. That is stream ordering. Right. Then if we try to check on map application, you can also get an area whereby they will ask you about the order of the stream. If there's a labeled stream and they will ask you about the order of that particular stream, determine the order at a given stream. Like for example, let's check on A, the order of A. Right, our A is there. If we want to figure out the order of A, it means A is made up of number 1. This stream is number 1, and also this stream is number 1. When they are joining, they are giving us number 2. And also this is number 1, and this is number 1. They don't have tributaries, these ones. 1 plus 1, it means the A is 2. And 2 plus 1 here does not change the order, it maintains 2. But after here, we are seeing that there's 2 here and there's 2 here. This confluence, it means the order is now getting to 3. So you should be able to do those to determine the order of a given stream, given that you now have the technique and you now know how to do the ordering. Right. Then let's go to river discharge. When we're talking of the river discharge, we're looking at the water that is flowing within the river channel. Right. The flow can be smooth or can be rough. Right. This, you can see the water is not flowing smoothly in the river here because the river bed will be uneven. It is having an uneven surface. It will also mean that the water will also flow unevenly because of the surface. This is what we call turbulent flow. There will be turbulence, meaning to say the water won't be smooth. It will be up and down, and it's turbulent flow. And this one where there is smoothness, the surface is smooth, the water flows smoothly over the bed, is called laminar flow. That is basically the distinction between those two types of flow. Then we also have the river processes that do happen in the river. We have erosion, we have transportation, and we have deposition. Right, let me quickly focus on the erosional processes that happen in the river. Right, we have erosion of material in the river. And under erosion, what you must note, you must be able to figure out the types of erosion that happen in the river channel. Right, we have number 1, we have what we call headward erosion. Then number 2, we have what we call vertical erosion. And number 3, we have what we call lateral erosion. Right, what kind of erosion is this one, which we call headward? This one is the type of erosion that is responsible for making the river longer. It lengthens the river channel, meaning to say the source of the river will always be migrating. As the source of the river is migrating, it also means the river is getting longer and longer. That is headward erosion. And then vertical, this one now is the erosion which is responsible for the deepening of the river channel. The river channel becomes deeper and deeper because of vertical erosion. Like if it's eroding like this, it will mean that the channel becomes more and more deeper with time. That is vertical erosion. Then lastly, lateral. Lateral, it means sideways. Sideways, what happens to the river channel? It becomes wider. It widens the river channel. So those are the three basic types of erosion that happen in the river. In case you get a question which asks you about the type of erosion, always remember that we have headward, vertical, and lateral, and you should be able to distinguish on how they affect the river channel. Right, we move on to the next aspect, which is the river's longitudinal profile. We are looking at the longitudinal profile. Remember, we have two profiles. We have the longitudinal and the cross profile. The longitudinal, we are talking of the river from its source right through until we get to the mouth. This is the longitudinal profile. And it's basically divided into three. We have the uppermost part, which we call the upper course of the river, and we have the middle course of the river, and we have the lower course of the river. That is basically the longitudinal profile. We're looking at the side view of the river from where it starts until where it finishes as it discharges into the sea. Then the cross profile, we're looking at the shape of the river from one bank to the other. Like if you check here, we have a more or less of a V-shaped river channel. From this side of the river to the across to the other side is giving us an almost V shape. This is the upper course of the river. Why does it have a V shape? The major type of erosion which happens there is also vertical, which is responsible for deepening the river channel, creating that V shape. Then we have the middle course. You can see on the middle course, it's slightly U-shaped. So its V is getting U to U here. The river starts to meander. You can see the river channel is bending. Here, the river channel will be almost straight. But here, because of the nature of the gradient, it's very steep in the upper course. But now the gradient is reducing. The river will start to wind. And is now a little bit wider. It's now having a U shape. Then in the lower course, the third part of the profile, longitudinal profile, where the river is now feeding into the mouth. The river now is very wide open. You can see there. And that is where we also talk of the floodplains developing and also the typical landforms of deposition like the deltas forming as the rivers feed into the sea. Right. We move on to river grading. When a river is regarded as graded, it means there is a balance or equilibrium between erosion and deposition. Whatever is eroded and whatever is being deposited, they are balancing up. And that is going to give us a smooth concave shape for the river. If a river is balancing between deposition and erosion, it's going to achieve a grade whereby the river is going to have a smooth concave shape. From the source of the river to the mouth, the shape is a smooth concave. That is a grade. The river will be graded. Then ungraded rivers, we are saying when either erosion or deposition dominates, those two are not in balance. Either there's more erosion and less deposition, or there's more deposition and less erosion, which will mean that the river channel won't be smooth because those two are not balancing. And that is going to give us landforms like the waterfalls here. This is a unique point. There's a sudden drop in gradient along the river channel, which will mean that the river is not having a smooth concave shape and therefore is not graded, is ungraded. That is basically with a river grading. The river is ungraded if it does not maintain or if it does not achieve a smooth concave shape from where it starts until it gets to where it ends. And also, what you should note there are the base levels of erosion, the lowest level at which a river can erode. That's the base level. And then the permanent base level, we're looking at that particular point where the river is now feeding into its permanent supply, or where it supplies its water into, like the sea level, that becomes the permanent base level. Then the local base levels, those ones, they can be removed as the river erodes headwardly. Like if there's a waterfall, we have a local base level. That base level is not permanent. It can be affected by erosional process as the waterfall migrates upstream. Right. Then the activities on river grading. Then an extract of Mapwork. You can also get questions on Mapwork, on stream ordering. You can be able to figure out which landform is that particular one. Or I can ask you about the stage of development of the river on a particular section, whether the river is in the upper course or in the middle course or in the lower course. You can figure it by what you see on the map. If the river is still small, maybe it's just starting, it automatically means that the river is in the upper course in its youthful stage. And also if you check, maybe the landform is still steep sloping, the valley, the river valley shows that it still is very narrow. It will give us supporting evidence that we are still in the upper course. But if you see the river channel widening on the map, it means now it's getting into the middle course. Or if you also see the river channel starting to wind or meandering, that will be in the middle course. As we go to the lower course, there's more of deposited material. You tend to find that the landforms that are going to form in the lower course, you tend to find like there might be maybe some deltas forming there, the wide flat plains. It means that the river is now in its lower course on the map. So those are typical questions that you can get when you are relating geomorphology to mapwork. Know the stage of development of a river at a particular given section. Be able to use the evidence to figure out which stage of development has the river reached on that particular part. Right, we'll move on to the next aspect. We are looking at fluvial landforms. Fluvial landforms, basically, we're going to summarize them. What you must note there, I will give special attention to the process of meandering and the formation of the oxbow lake. Then I also give emphasis to the braids, and also can give a special emphasis to the process of basically those aspects. Right, let's start with the first part on the meanders. Right, I will try to illustrate as quick as is possible so that we have a clear understanding, and also we need to relate some of those concepts to the mapwork part. Right, what are we saying here? We are saying we do have a bend along the river channel. That is what we call a meander. Like we are saying, the river channel is not flowing straight, but is taking a winding route. If the river is flowing like this, it's not flowing straight. Our river says the direction of flow is that one. It's that one there. It's going in that direction. This river is meandering. This is what we call the meander. The river is bending. And what is the implication of the bend along the river channel? It implies that here, if there's a bend, the water is going to be flowing faster on this outer curve of the bend here. And the water is going to be slower on this part of the curve here. Water has got capacity to flow faster here because this curve is not very pronounced. But this curve here is very blind, and the water will reduce its velocity. So on this part of the bend here, this is what we call the outer bend. It's the outer, and this one is the inner bend of the meander. On the inner bend, because of less velocity of the water, we have deposition happening here. Meaning to say, there will be material that will accumulate here because of deposition. And here, because the water is much faster, we tend to have erosion happening on that side. And as such, that is going to give us the shape of the river channel being different from this side to this side. If you are to draw a cross section along this line from A to B, how is it going to look like? Because we are saying there's erosion taking place at A and there's deposition taking place at B. This is going to give us this shape of a landform, which will develop. Starting from A, if you are to draw a cross section, A is there and B is here. We are saying at A there is erosion. So it means the river channel is going to be steep like that because it's being eroded. But as we come out of the channel going towards B, we say there's deposition. It means it's going to have a general gradient going towards B. There is deposited material here, closer to B, and there is erosion happening here. This is if you get a question which asks you to draw a cross-section through a meander, always remember that the shape of the river channel will be steeper on the side where we have the outer bend. And where we have the inner bend, the river channel is going to have a general gradient because of deposition. This is what we call the undercut slope. It's called the undercut slope. And this one is called the slip-off slope of the meander. So those are the basics that you have that you need to know, because they are basically asked in the examinations. You should be able to figure out such a drawing of the cross-section, taking it from the meander, and be knowing how the activities differ there. The river processes of erosion and deposition, they differ on either side of the bend. And that will lead us to the development of the oxbow legs. The oxbow legs, because of continued movement, if the bends are adjacent to each other, it means on the end side of the outer bend is going to keep on eroding until it fuses to another bend and creating a straighter channel that is going to create the oxbow legs and ultimately the meander scars. Right, we move on to the next aspect. Right, we have braided streams. You can see here, when we have a braided stream, we are saying we have multiple streams which are interconnected within the same channel. Like if you can see here, this is an island within the same river channel, but if you check, the river channel is this wide from there getting to there. But within the river channel, we are having these sandbars, or we're having these islands which have developed within the river channel. And as a result, the water is now going to develop into splitting streams. The streams are going to split because of the deposited material. Or these are what we call the braids. They are basically formed because of a deposition within the river channel. Because material is being deposited there, and the river will now, like, it's blocking its own path and is forcing to split into streams which are multiple but within the same river channel. And also these sandbanks, or those sediment material, they are also unstable because it's material just being deposited there within the river channel. There was a question in the Gauteng prelim, question paper 1 on geomorphology, which was asking about the safety of the tourists. The question was asking about why tourists must not set camp on those islands. And the proper response, those islands are within the same channel. Within the channel, they are prone to flooding. They are not safe because if there's a flood, they can get carried away by the flood water. Or the material is also not stable. It's just sand material which can be deposited, which is just being deposited there, which means we cannot ensure safety because of the nature of the material, which is unstable. So basically, you need to relate. And also the other thing, I think there was a question which was requiring you to draw a cross section. Drawing a cross section through a braided stream, you should not, if you are drawing a freehand cross section across a braided area, take note of the braids and take note of the depth of the river channel. It will mean that if the river channel is like this and they ask you to draw maybe a cross section, a freehand cross section along that line from A to B, it will mean that your cross section must encompass and must take provision of the development of these sandbars within the river channel. And it will mean that as you draw, where there is water, it means we are in the channel, it's deeper. And as you go towards the braid, or the braid as in the sandbar, you have to elevate your drawing, meaning to say you are going over a higher lying area. This will be your island. And then if there's water, like we are going via this line, there's water again, it means you're going down again into the channel. It goes up on the other braid, then we'll go back to the channel and you get to where the river is ending. So it will mean that maybe if you're drawing from A to B, you'll be having a shape something like this. And these are your islands. So it's typical practical drawing by just noting the nature of the braid and relating the height of the features to the given space and being able to draw a free-hand cross-section along a given line. Then we have the floodplains. The floodplains are simple. Floodplain is basically the area on the sides of the river where material gets deposited when we have a flood. So in that area is very significant for agriculture because it provides fertile soil for agriculture. And also it's a flatland which is easy to even use machinery for agricultural purposes, and also can be used for tourist attraction. That is basically the floodplain. We're looking at the flatland which is adjacent to the river and is predominantly in the lower course where there's more deposition happening. The floodplain will be very fertile and will be wide. Right, we go on to the natural levees. A levee is an embankment by the sides of the river. An embankment, we are saying there is material which is going to be deposited by the sides of the river here. So this is typical of material which was carried by the river and was splashed outside the river channel and accumulates, creating an embankment by the side of the rivers. And basically these landforms, they help in reducing the risk of flooding because they will be elevating the nature of the landscape by the side, meaning to say they will be helping in containing water within the river channel. So these are natural levees, those that occur naturally because of the deposited material. We do have artificial levees. I think if you have checked some rivers, there is the development of some embankments which are man-made along the river channel to reduce the risk of flooding. So these ones are natural. They occur naturally because of deposition. That is why we call them natural levees. Right, we move on to the next one is the delta. The delta, basically the river is now splitting into distributaries as it gets into the mouth, like what we are seeing here. It's one river, but now as it feeds here into the sea, it's now splitting into different distributaries. That is basically a delta is a landform which forms in the lower course of the river because of deposition of material, and as the river feeds into the sea, it now develops some distributaries. Right. Then we have a waterfall. Waterfall basically is a landform which forms when there is a hard and resistant rock along the river channel, which will make the water to plunge vertically down and create at the bottom what we call the plunge pool. Like what you are seeing here, if you are having a resistant rock, this rock here is not easily eroded, but the underlying rocks are softer. It means the water now will start eroding the underlying rocks which are softer. And then because of the sharp gradient that is going to develop by the cap rock, it is going to force the water to plunge vertically down, going down the neck point. And it's going to create at the bottom what we call a plunge pool. There will be a pool that's going to develop at the bottom because of the plunging effect of the water. Is called the plunge pool. And then maybe what you also need to note is the aspects related to waterfalls, their significance in geography. Much of the waterfalls, they are tourist attraction centers, or they can be harnessed for hydroelectricity generation, or they can provide opportunities for leisure or for fishing. Those are typical aspects that you should just take note of. Then when we're talking of rapids, rapids are basically, to be specific, a rapid is basically is basically a smaller version of a waterfall. Like you can see there, the water is plunging, but this one is not pronounced as a waterfall. It's just a smaller version of a waterfall. It's a rocky area where there are resistant rocks, so the water tends to flow very fast and to be tumbling over those rocks. Like what you can see, we're having white waters there is because of the nature of the flow of the river as it goes over those surfaces. Right, then we need also to look at Mapwork application. You need to know areas where we have waterfalls. On the map, we should figure out sense and figure out geographical arguments as to the existence of waterfalls on the given part of the map, and also the different landforms. You need to figure them out, like the meanders on the map. You need to see them and be able to justify their existence. And also, I talk of aspects like those braids. You can also visualize them on the map and also justify their existence. And that is basically referring the fluvial landforms to Mapwork skills. Right. Then we have river rejuvenation. Right, with the river rejuvenation, when we're talking of rejuvenation, we are saying the river is regaining its erosive power. The river has got more power to cause erosion. And what kind of erosion is predominant is vertical erosion. The river starts to erode vertically or to deepen its channel after gaining power. So the definition is simple. The river regains its erosive power. The river now is getting younger, is now having more energy to cause vertical erosion. That is basically the definition of river rejuvenation. Right. What might be the causes of river rejuvenation? What gives the river energy to start to erode again? Is a drop in sea level. If the level of the sea gets lower, it means now the river has to erode the whole channel upwards to attain a new base level, to attain now a smooth concave shape, which is realized from the new level of the sea. And then increase in rainfall. If an area receives more rainfall, it means the rivers will have high discharge. And with high discharge, it will also mean that the river will regain its energy to cause erosion. Or stream piracy or river capture. If a river intercepts headwaters of another river, it means it now has higher discharge and is now likely to cause more erosion along its course because of the additional water which has been intercepted from another river. Then isostatic uplift. If an area is uplifted, maybe it's folding, which has happened, it means the steepness of the landscape is also going to be altered. The river will have to flow over a steeper surface. So the steeper the surface, it also means the velocity of the river is going to increase and apparently is going to cause more erosion. And then lastly, decrease in stream load. If there's less load, it means the river will be flowing faster. And then it's going to cause more erosion. Then what is going to happen? The landforms that are going to happen, we have terraces. Terraces, those are basically stepped sides of the river. If a river rejuvenates, it's going to create a channel within a channel because of vertical erosion. That will lead to the development of stepped sides on the sides of the river. Then a nick point. We are looking at a nick point, for example, a waterfall can develop along the channel. Where the river is now meeting, there's a new profile which is being created. The river is now trying to create a new channel, but however, if it meets an area of resistant rocks, it will not effectively co-join the old one to the new one, and that is going to create an area with a sudden drop in gradient, which we call the nick point, like what is indicated. Then incised meanders, because we talked about meanders having some erosional processes taking place on the outer band. They will be incised, meaning to say they will be deeply cut into because of the velocity of the water and the energy of the water. It means the bends of the river are going to be very deeply cut into because of the impact of the power that the river will be having. So basically, if you are looking at those two, a river which has rejuvenated, it will now get a deeper channel like that one there because of the erosive power, which will be vertical erosion. Then we go on to river capture. I think this area here is very important for you to understand and for you to figure out so that we do not have complications in the examination. Right, river capture. Basically, I've explained what river capture is. We are looking at when a more energetic river intercepts the water of a less energetic stream. Here, I want to emphasize, you must not use a bigger river intercepting a smaller river. It's not about the size of the river, but it's about the energy. A river which has got more energy, it advances headwardly until it gets into another stream and it intercepts the water into its own supply. What should you, what must you note? Let me summarize it quickly. Right, we are saying we are having one stream, and we have stream A is flowing in that direction, and we are having maybe stream B is flowing in that direction. These two streams have got their tributaries like that as they flow. And we are saying there's a watershed in between here, which is splitting stream B from stream A. But however, because we are saying one is more energetic. Let's say it's A, which has got energy. A maybe is flowing over a low-lying area and is having energy. Its tributaries are going to advance through the watershed, and apparently they are going to join the other side of the watershed. And it means the moment this happens, the water now is being diverted. Water which was supposed to feed into this stream is now being diverted to come and feed into this one. So this is the process of capture that we're talking about. An energetic river is this one, is advancing, is eroding headwardly, is lengthening each channel because it has energy, and it will end up getting to intercept water of the other stream here, which means now the water is going to be diverted into the flow of stream A. That is basically the process of river capture. Then there are key elements that you need to note, right? We have what we call the captured stream, like what we are seeing here. Right. Captured stream, we are looking at the stream whose water has been intercepted. The stream. Then if you check, we have headward erosion. Headward erosion is basically the erosion which is responsible for lengthening the river channel. So what does it mean here? We also have the capture stream. The capture stream is the stream which intercepts the water of a weaker stream. So it means if river A is the capture here, it is going to cause headward erosion. Headward erosion in the sense that is going to lengthen its channel, and it will end up getting into the area of river B. The moment it gets here, the water now diverts, it feeds into here. So basically that is the process of river capture. We have a captured, this has lost its water, and the captor is the one that has intercepted the water. And we have headward erosion, which is responsible for lengthening the channel. And we also have what we call the elbow of capture. Like we are seeing, an elbow becomes now this bend here, where the process of river capture has happened. Here, the water now is going to bend to feed here. So this bend that is going to be created is what we call the elbow of capture. Then the wind gap, because now there's no constant supply of water, this part might dry up and the river might continue downstream. It has lost its original supply of water. There's going to be a gap that is going to develop there. That is what we call the wind gap. So basically you should know and be able to label those parts of the process of stream piracy and be able to figure out. And then you should know the implications of river capture. If a river has lost its water, it has got both negative implications and positive implications. If stream piracy has happened, it is going to affect positively the human activities, maybe on settlement, on recreation. You must be able to also explain. And as you explain, remember, you must give your factor and you must qualify your factor. Right, that is the process of stream piracy, or the process of river capture. Right, I will quickly explain on antecedents and superimposition. Right, with the antecedents drainage, we are saying there is a situation where you find that the river's flow direction does not conform to the topography of the area. Like we are saying, a river is cutting through a high-lying area. A river cutting through a ridge. How did the river manage to cut through a high-lying area? It's either because of superimposition or antecedents. In this instance, we are saying a river can be imposed on a particular landform. The landform was there initially, like what we are seeing here. This landform was there before this river. It was existing underground. It's still hidden, and the level of the earth's surface is still higher there where the river is flowing. So when we are saying the landform is older than the river, we're saying the landform was there, but was hidden underground. The river was still somewhere up before it got to impose itself on the landform. So the river is flowing, but the landform is underground. But gradually, because of erosion, the river is going to lower itself until it gets to reach this landform here. And because the river will try to maintain its course, it is going to cut through that landform like what you are seeing here. it will manage to cut. It has superimposed on the landform. It has visited the landform which was hidden underground. It imposed its course on top of the landform, and because of erosion, the river will manage to cut through the landform, which will mean that we can have a river here now which is cutting across a high-lying area like what we are seeing here. This area is high-lying, but the river is managing to cut across the high-lying area. This is superimposition. The river is younger than the landform. The landform was there before the river, but the river now got to impose itself on top of the old existing landform, and because of erosional energy, the river managed to cut its course through the landform. Then antecedents. We are saying with antecedents, the area was initially flat. But however, because of some isostatic upliftment or because of folding, the topography of the area got to change. So it means now the river is the one which is older. The river was there before the landform got to be altered by tectonic forces. So in this instance, the river was there flowing on a flatland, but however, because of the tectonic forces, they got to fold the area. But as the folding is happening, the river will also slowly manage to maintain its course by cutting through the area which is being uplifted, such that at the end, despite this whole area being uplifted, the river has created a gorge across the high-lying area. It has managed to cut across, because as the landform was being uplifted gradually, the river was maintaining its course, cutting through the area which is being uplifted. That is antecedents. So the difference there is superimposition. The landform is older than the river. It is the river that got to superimpose itself on top of the old existing landform and managed to cut across it. With antecedents, the river is older than the landform. Initially, the river was there over a flatland, but however, because of tectonic forces, the area got to fold and got to uplift. But as it was uplifting, the river managed to maintain its course across the higher lying area which was developing and maintain its course to cut across it. That is with superimposition and antecedents. Right. Then now we move on to the last part of geomorphology. And this is the most easy part of geomorphology, where we talk of river management. River management, we are just looking at ways of management of water resources and our basins and our catchment areas, so that we are guaranteed of the supply of clean and safe water. So there are different ways that should need to be put in place for us to attain river and catchment management. We have poor river management. We are saying we are failing to manage effectively our water resources or our wetlands. That is poor river management. And what causes such is indicated, for example, inadequate sewage collection, or cutting down trees, or agriculture, which causes pollution because of fertilizers. That is poor river management. If we cause those activities, we are poorly managing our rivers. And why is it important that we manage the rivers? Remember, our water comes from the water sources. We need to be guaranteed of the supply of water which is safe for use. So we must manage the water sources to get adequate supply of safer water for usage, either in the at a domestic level or at industrial level. Then also the water sources, we use them productively in agriculture, or we also need the water for industrial purposes. And also we need also the water for domestic purposes or for sports, for generating electricity, hydropower. So which means it's equally important for us to be able to now implement measures to manage our drainage basins, so that we are guaranteed of those provisions from our drainage basins and our catchment areas. Right. Then what the impact of people? How do people impact? They cause river pollution. Pollution from agriculture, pollution from the household refuse, pollution from fossil fuels. They all get into the rivers and pollute the rivers. Then untreated sewage. We have instances of leakages of sewage pipes, and such sewage is going to end up into water resources. That is going to cause a negative implication on the water resources. And other activities like deforestation, overgrazing, and settlements, for example, mainly the informal settlements. Some of them are not are developed in areas which are very close to the rivers, and at the end, human activities will interfere with the flow of the river and ultimately affect the water resources. Then we also have industrial waste. I think it's typical. Some industries, they do pollute the river or the water sources, which will also mean that they are going to compromise the quality of the water resources. Then what should be done to make sure that our drainage basins are safe? We must maintain vegetation. Also can use the legislation, which means the laws. Educating people is very important. Some people harm the environment out of lack of knowledge. They must be made aware through educational campaigns. Or you can do international cooperation to manage rivers, or wetlands must be conserved. Avoid construction and settlements on the floodplains. Very clear. If we settle on the floodplains, we're going to affect the catchment areas. So basically the questions that you might get on that part, they will be asking on the strategies that can be put in place. Ensure that you come out with sustainable solutions or meaningful solutions that are going to solve such problems. And also they must be within the reach. Maybe the question is relating to maybe a certain municipality. Usually you get a case study, and that case study will be having some other extraction questions. Ensure if a question is a quotation question, quote evidence to support mang. You must just go to the source, extract the information as it is, and be very precise to get the information as it is. And if it's a question, or maybe it's a paragraph question, then find solutions which are sustainable. Maybe the question is saying, discuss how the municipality of whichever town can be able to maintain the water resources or can minimize the harmful effects on the water resources. You must come out with sustainable and meaningful and feasible solutions. So basically in preparation for the geomorphology question, remember all those aspects. Is geomorphology question number 2, and you must attain the highest possible mark in that particular section of geomorphology, which is question number 2. And also in question number 3, we have aspects related to geomorphology, either in map calculations or maybe it's the GIS part. You should also be able to figure out such that at the end, your final score is very high and pleasing. And it is very possible. It just needs a determination, and it just needs you to be real. Be real to yourself, maintain self-confidence as you get into the examination. Do not get distracted and focus. And also try to understand the key aspects of the question before you answer the question. Scrutinize the question and be able to figure out the demands of the question before you answer it. And as you answer, ensure that you follow the factor and the qualifier. Give an answer to the question and explain or qualify that answer. That is basically how you should go through your questions, and at the end, you will get a very good grade. If it's sketching, use your skills of drawing. Draw a free and cross section from whatever area to whatever area. Be able to figure out the indications of height and also apply the knowledge. How is the slope like on this part of the area? How is the slope like on this part, because of the different aspects that will be happening there. And definitely, much of the questions also might be application questions. If you get an application question, just try to think like a geographer in the world. What actually is happening? How can we solve such problems? Do not limit yourself to the book. In as much as you are not saying the book does not help you in the examination, it helps you, but in some other instance, you need to be real. You need to be a real geographer in the world. Try to figure out how best we can deal with some geographical problems, or how we can improve our geographical understanding within the reach of our environments. Right, so basically I think our discussion has come to the finalization. We have reached the part that we thought we were supposed to cover for geomorphology, and I hope your examinations will be fruitful, and there is nothing that is going to come outside of what we have covered. It means what you only need to do is to get to understand the question and still remember the content and apply the content to the given context of the question. Then everything will definitely go very well. So I hope you are going to be blessed, and you're going to write well, and you're going to get your intended good grades. It's me, your host, Conrad Mupinguri. Thank you.